Good morning. Welcome to Orlando and welcome to the conference. I'm Sing-Wei Chu. I'm here to serve you as one of the conference organizers. Today, this morning, we have 4 speakers. So what we decided is we hold the question till the end of the all sessions. The speakers will stay to answer the questions at the end. Our first speaker is Professor Thomas Marlowe. Professor Marlowe is the program advisor for computer science. He has been a member of the Department of Mathematics and Computer Science in Seton University. And his research interest is many different areas. In mathematics is abstract algebra and discrete mathematics. In computer science is programming language, real-time system, and software engineering. And in information science is collaboration and knowledge management. He got his PhD in computer science and also another PhD in mathematics, both from Rutgers University. And he has over 70 publications in refereed conference and journals in mathematics, computer science, and information science. So please join me, welcome Professor Thomas Marlowe.
Okay, if I can fit anything else in my pocket. But that's a different question. Oh, let's see if I can make this work. Sorry about this, hold on just a second. Turn this mic off, right? Don't worry about it. All right. I suspect that except for the electronics, people would be able to hear me anyway, but let's see. So, let's see if this works. There we go. Okay. All right. So I only need 1 copy, thank you. That's all right. So we've had a number of excellent talks from quite a few very good speakers on systemics, second-order science, and the relationship of the individual to problems. And what I'd like to talk about is why that might need to be enhanced in some cases. So let's look at the systemic view. A large theme is going to be the relation of the observer and the observed. And let me begin by tracking back to problem solving. And I'm going to keep using this notation. I begin with a problem that is, how do I do B? And I come up with an answer that says, this is a way to do B. Or the best way, or a good way. Sometimes even this is why I can't do B. Okay, and the problem interacts with the solver. You'll forgive the primitive stick men, I hope, and they may be stick women. I found it hard to put the skirts in. Let's call her Alice. And so the systemic view is the problem is interacting with the observer, the problem solver. So there's this little box, and that's observed by the problem solver, and this is of course recursive, so I could put in an infinite number of boxes, but I decided I probably wouldn't have the talk ready if I tried. Okay. And there's contextual information. There's always context. So actually I wind up solving the problem in a knowledge context and in my own experience in the real world context. Even a theoretical problem is influenced by what other people have done, by my ways of looking at things, and so on. And both the problem and the context evolve. So what might have been a solution now becomes something that isn't exactly a solution in many cases. Some theoretical problems can in fact be solved absolutely once and for all, saying this is the solution or there is no solution. But in most cases, we need to take account of the fact that the solution is very dependent on what we know. Now, how does this interact with software engineering? Well, let me call up two famous people, Abraham Lincoln This view we just saw is very nice if I assume that Alice is the only person around looking at the problem. Or even that Alice and a group of researchers with a common background, context, are communicating and working on the problem. But that isn't always the case. Often someone else tells me, solve this problem, or it would be nice if you solved this problem. And they don't necessarily have the same context. And I don't necessarily do it by myself or with people who have the same context. I'm often working with a team of people who have different contexts. And the final solution of the problem, in many cases, has to be usable. Not by me, or not only by me, not only by my colleagues, not only by my managers, but by a different community. And the basic problem is that context changes, language changes. So my second famous person, Goethe. And instead of mathematicians, we can use computer scientists, software engineers, second-order scientists, whoever you like. Philosophers, ethicists, managers, marketers. So the client says, okay, I've got a problem, and I want somebody to solve this problem. I'm going to tell them what the problem is. I'm going to send out a request or a demand. Somebody's going to do it and tell me what the answer is. Yay! Okay. And the developer's looking at this. Let's call her Doris. And saying, okay, I see that there's this problem from Alice, and she wants me to solve it. Let me try. So Alice gives Doris the problem, and now the problem is that it's not the problem that the problem was stated in Alice's language, and Alice understood what it was, but it doesn't mean the same thing to Doris. And in fact, her context is also different. And so Doris solves the problem, and Doris passes it back, and now Doris's language becomes another language to Alice. And Doris says, this is the solution to your problem, but it means this is the solution to my version of your problem. And Alice sees it and says, this is the solution to Doris's version of my problem. And I hope it's the solution to my problem. I hope. And even this is difficult enough. But now the problem is that Ursula also gets involved, the user, and she sees this solution and says, okay, so she also knows about the problem. This is a solution to the problem Alice wanted to provide for everybody. But, of course, Ursula is also using her own language. And her own context. And it's not the same problem again. So, where can we go? how do we ensure that we're actually communicating across contexts, across languages, across knowledge bases? Well, where are the problems? We saw that we get big changes in the handoff and delivery, and then if Ursula is involved in use. And this comes about because of difference, and I've referred to a number of them, in background and expertise, in the environment, by which I mean the technical as well as the social environment, in the problem languages, in the context, in background knowledge, and in expectations and objectives. And what are we missing? I said requirements, and I'm classifying a lot of dimensions there, but basically I need to deal with interoperability, make sure that things act the same way in everybody's universe. Requirements, make sure that the needs of each of the groups are met, and that's really requirements analysis and management. Knowledge management and transfer. Verification and validation. You remember that step, and I'll get back to it, where I hand you the solution to your problem, I think, and you say, well, this is the solution to my version of your version of my problem. Let's make sure it's the solution to my problem. Verification and validation. Various software engineering approaches, and I'll go into that a little bit later, and complications in maintenance and evolution. So interoperability, make sure there are channels for communication, make sure that things that more than one of the parties have to do have, as nearly as possible, the same meaning and effect. You can think of that as the semantics and the pragmatics of the operations, and that we know what functions and what people are responsible for what pieces. Requirements, figure out what we know about the domain, say banking, and what we know about the discipline, say mobile computing, networking, security. Elicitation, go to the various stakeholders. Grandin talked quite a bit about that yesterday in the workshop. Make sure you talk to all of the stakeholders, in particular all of the groups in the client. Make sure you know what they need, what they want. Make sure you understand what they think the product is. I'll talk a little bit more about that when I get to knowledge in a minute. And then check your requirements. Make sure that you've got, as nearly as you can, enough information to get going, that they make sense, they don't contradict, there aren't ambiguities, and make sure they're clear enough to work with. I know this is not surprising once somebody points it out. Okay, and you need to learn to ask questions, to consider difficulties and risks, to consider expectations, and to evaluate comprehensibility, completeness, coherence, and clarity. You need to look not just at the statement of the problem, but Doris needs to understand Alice's context and knowledge base to be able to solve the problem. Okay, knowledge transfer. We need to at least try to understand the vocabulary that we're dealing with, the meaning of terms. We, again, yesterday in the workshop, we got into a fair amount of both presentation and then discussion of what complexity meant and complication. And Professor Gill presented 3 dimensions, and several of us argued for maybe 2 or 3 additional dimensions. And if I'm addressing some of his dimensions and he meant other dimensions, it's not going to be very good. I've run into this a couple of times recently. I was talking to a student I was working with on a co-op who said that he was actually close to finishing and had been working as a CIO for a Nevada company for a while. And he said that he had told his boss that this project they were doing for the state needed very high security. And he said, well, the building it's in will withstand a nuclear attack, but it will be very easy to hack the server, because there were very different understandings of the meaning of the term. You say, I want my software to be usable. Are we talking about ergonomics, aesthetics, comprehensibility, disability access, availability? Which of the following, which are more important, which are critical in the sense that they represent constraints and not objectives? And I'm sure if I wanted to take 10 minutes or more, I could come up with a half dozen more. Identify knowledge that we assume is shared. I assume you have to know about this. It's so obvious. And make that explicit. Isn't it clear that management has the objective of whatever? The answer is, gee, no, I'm a programmer. Isn't it clear that pushing this button, this label, and again, sorry, I'm not thinking well, is what I would push to make the computer do that? No, it's not. Change the damn label or provide an explanation. I know this has, going back to usability, I remember hearing about a case in the Navy where they designed a sensor suite for an operator, and they made sure the operator had all the information and could have all the controls he or she needed. The only problem is that with the layout they used to make it work, the operator had to sit on his back and have his shoes off, because otherwise he couldn't reach all of the controls that he might need to use at the same time. Okay, implicit, text, tacit, and contextual knowledge. Tacit, hands-on knowledge. Watch somebody use a lathe. Walk forms from one place to another. Things that, unless you ask, people won't tell you. Maybe don't have it even articulated themselves, or in some cases can't tell you. But no matter how hard you try, an artist may be able to tell you the mechanics of how to paint something, but can't really convey the aesthetics except by saying, look at what I do, and then try it yourself. Okay. Verification, validation, testing. The obvious purpose is to test for errors and fidelity to specification. But do what I told you to do is less important than do what I want you to do. So one of the purposes of validation is to make sure that I'm actually solving the problem I was given, instead of the problem I understood, even if I understood it correctly and literally. Okay, software engineering. The key idea here is to try to reduce the communication in various ways by putting everybody in the box. So, in this case, I've changed Alice to Carol, the client, Doris, the developer, and Ursula, the user, are all involved in the design and development, are all involved in the specification of the problem, are all involved in the use of the problem. And there are various approaches for this. Focus groups to try to get the technical people and the management people, the technical people and the users, the technical people, the management people and the users, the developer to management and the developer technical, lots of different groups together to try to figure out what they want, what will work, what won't work, what's to be prioritized. Use cases and function lists to try to figure out the patterns of interaction and whether they correspond to what's expected and what makes sense. And what, in this case, thinking about a software application, the application has to do, and how, for that matter, corner cases and exceptions and so on have to be handled. Classical prototyping. Don't wait until the end to show the product to the manager and to users or user representatives. Try to do it as an ongoing basis. Ongoing interaction with the client and users, agile methods, co-design, co-creation, living labs, which always sounded to me like a character out of a horror movie, but that's a different question. Adaptive methods and agility begin with a partial description, start working as you go along, talk more to the client, talk more to user representatives, talk more to your own management, try to figure out how to make the thing iteratively converge so your version and the client's version and your manager's version and your user's version converge. And establish trust, establish sharing of knowledge and context, technically, socially, culturally. And this one got too big to show. I think I would have needed about 30 boxes. So I decided I'm not going to box this one. The problem is I get multiple changes in context, problem and perspective, and the new difficulty is translating user reports of problems. So now I not only have, or of desires, or and so on. I not only have to translate going forward, I have to translate going backward. And then I have to take that report and check sometimes with the client and say, is it feasible to do this? Do I want to do this? Can I make this change? Will you pay for this change? Okay. And I have to decide who's responsible. In most cases, it's going to be Doris. And I have to handle, in particular, a discord between client and user expectations. And I have to continue to apply all of these processes. Okay, there are further problems I haven't dealt with arising from multiple developers or multiple teams of developers, multiple organizations doing the development, multiple clients, multiple user groups, and additional stakeholders such as regulators, standards bodies, subcontractors, vendors, suppliers, people who develop services, infrastructure providers, the general community in the discipline or domain, et cetera, et cetera, et cetera. Okay. So conclusions, the first conclusion is the classical systemic view. I'm going to read this one actually for a change. Assumes coherence of perspective and context. There's one individual or one group or one community looking at a problem who are involved and have feedback. And when you get to multiple communities, other issues are raised. And we have to employ a toolkit to adapt. And fourth bullet, if I could have fit it, is the toolkit won't solve all the problems. It's only an approach to try to eliminate the worst ones. And finally, I'll let you read that. And thank you.